Can you please not kick the door when you enter?
Yeah, I don't care. Look, I discovered something that proves NASA is lying.
Did you? How's that?
Look at this.
Oh, the first picture of the black hole, taken by Cathy Bowman in the year 2019.
Yeah, do you notice anything strange in the picture?
I mean, the black hole is already a strange thing in the universe, but if you mean something that we didn't know about the black hole before taking this picture, then no, I don't know.
Okay, here's the thing. Light is made of the photons, right? And photon is a particle with no mass. Or wave, I don't know, get some kind of... In the picture, we see that the light of the star falling into the gravitational pull of the black hole.
What's so funny? Everybody knows the gravity of the black hole is so strong that can even pull the light. I mean, look.
Black holes are among the most fast. Is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the
How
horizon.
do you... Yeah, I was also surprised when I first heard about this.
Now wait a minute. How the massless light is affected by the gravity?
Well, we will talk about it now. This great and vast universe, which is full of galaxies, planets, nebulas, and different kinds of stars and other cosmic bodies, is controlled by four forces in the universe: gravity, strong nuclear force, weak nuclear force, and electromagnetic. Today, we will talk about only two forces, electromagnetism and gravity. The rest of the two will leave it for another day. First one, gravity. Gravity is the great force that makes up all the planets, stars, and galaxies. Gravity is formed as a result of movement or the presence of the mass in the spacetime, which is represented in the form of curvature in the spacetime. Gravity is considered as the first force formed in the universe after the Big Bang, and gravity was formed 10 to the power of minus 43 seconds after the Big Bang, which also means that the gravity was formed after 0. There are a lot of zeros. After 0. billion seconds after the Big Bang, the force of gravity was formed and hired in the universe factory. In the beginning, when Newton discovered gravity, he believed that gravity comes from the center of giant bodies such as Earth, planets, and the Sun. So gravity pulls you to itself when you jump. Isaac Newton is a mathematician and teacher at the University of Cambridge and was also a member of the British Parliament. He was sitting near a tree reading a book. Then he was looking at the moon in the daylight, and an apple fell before his eyes, and he wondered to himself, why does the apple fall, but the moon still orbiting? Here the idea of gravity was formed by Newton.
I mean, how can we call him the guy who discovered the gravity? Gravity is a very obvious thing. Leave something on the air and it will fall.
That was mine.
Anyway, what makes Newton the first guy who discovered the gravity?
It is true. Gravity is a very clear thing, and it is certain that there were people before Newton who discovered gravity, such as Galileo Galilei or Brahmagupta II. But Newton was the first person who wrote an equation for the force of gravity and established a special physics for it, which is called the classical physics. In 1915, a young German intelligent guy named Albert Einstein, or in German Einstein, did not believe that the gravity comes from the center of the mass like Newton did. Einstein hypothesized that the gravity is caused by the curvature of space and time that exists throughout the universe. Newton believed that the gravity pulls you down, but Einstein believed that the gravity pushes you down closer to the object that has the greater mass. In short, space-time tells matter how to move, and matter tells space-time how to curve. This space-time curvature discovered by Einstein, it turns out it's not only causing gravity, but it's also changing the form of time. And if the curvature of the planet number 1 much bigger than planet number 2, the time will be slower in the planet number 1. Why does time slow down under strong gravity, you ask?
I didn't ask.
Well, we will talk about it in the next videos. But until that day, this is the only thing you need to know about gravity. The light. As we know, there are 13 types of particles. There are 14 types of particles in the universe. 5 of them are the particles that generate the 4 forces in the universe, which are known as the bosons. Boson W and boson Z cause the weak nuclear force, and the gluon is responsible for the strong nuclear force, and the photon is responsible for the electromagnetic energy. Let's talk about the creator of electromagnetic waves and the light in the universe. The photon. Photon is a small particle that emits waves of electromagnetic radiation. Also, the Scottish scientist James Clerk Maxwell discovered that the photon is only an electric field moving in the space-time. A photon is formed when an electron in higher orbit returns to its normal orbit. During the fall from high energy to normal energy, the electron emits a packet of energy and ejects from the entire atom system. This packet is called photon. The photon is responsible for this beauty and the different colors that we see in our lives on Earth or in the universe. The presence or absence of the photon is very normal in space, and you don't have any reason to be afraid of not having photon in your room.
Hello? Oh my god. There's a lack of photons in here. It's very dark. Woo!
The photon moves at the speed of light in space, which is 299,792 kilometers per second. The reason lies in the fact that the photon does not have mass at all. If the photon is a particle with no mass, why does it interact with the gravity and move on its curvature? There are many pictures, equations, and other proofs. We reached this conclusion that light is bent by gravity. Did you know I wasted a lot of time on this video and still I didn't get my answer? Hey, you're the one who asked this question. I just want to explain it in the best way. Let's imagine space and time in the form of two-dimensional squares. The line or the body moves on the space naturally. If space is in a three-dimensional shape, we will notice the curved movement of this body in space and time. When we observe it in two images, we notice in the normal case that it moves on a straight line, and this is what happens in reality. The light here did not come out of the gravitational laws of space and time. It moves on the space itself, even if its shape is curved from another dimension. Put two men on the Earth timeline and you will see that in a flat shape they move in a straight line. But if it's spherical, then these two men will meet, and that's because of the curvature. We gave you now an example for the flat and positive shape of the space. But now let's imagine it negative, and the picture will become more clear to us. Therefore, when we see the image of the black hole swallowing the light, it is normal because it moves in the direction of the space that the other side of the black hole indicates, or after reaching the singularity point.
Wait, other side? Singularity? I am curious. What is there?
Haha, we will never know because you will be probably crushed and teared apart to your last atom of your body. Lucy Hawking explains the process of entering the black hole in the most simple way, in her book, Unlocking the Universe. In the page 213, you can see how the words are disappearing the more they enter the black hole. Very good and useful book, by the way. This is one way to solve it. The second way is related to the quantum mechanics. We know the famous equation E equals mc squared, which every nerd in the world claims to understand what this equation means. It is the equation that shows every packet of energy has an equal amount of mass. So, if we assume that the energy and the mass of the photon are equal, it is normal for the photon to fall into the curvature and interact with gravity. So, as a result, every study that says the photon is massless is wrong, and every information that we said in this video are useless and we wasted our time for nothing. You're a sick man. Well, don't blame me, it's all because of the quantum mechanics. Nope, I'm done with this. I'm gonna get out of here. Now take this trash out of me. But wait, what about the end of the video? Well, today we tried to give a brief explanation for the light and gravity and why they do interact with each other. Perhaps in the future we will explain them more. But until that day, do not stop wondering and be curious.